Hey there, future coders. Welcome to today's explainer. We spend literally all day tapping on screens, playing games, sending messages, but today, we're totally flipping the script. We are stepping behind the screen to figure out exactly how we communicate with computers using code.
So I want you to start by thinking about this really simple but kind of mysterious question. How does a computer actually know what you're thinking? I mean, seriously, think about it. A computer is basically just this fancy box of metal and electricity, right? It doesn't have a brain, it doesn't have ears, and it definitely can't read your mind. So when you want it to do something, how in the world does it know what to do?
Well, the answer is code. To communicate, computers need incredibly specific instructions. So in this explainer, our mission is to decode the secret text-based language that tells computers exactly what to do. We're going to learn how programs get information from you, how they hold on to it, and how they actually talk back.
All right, let's dive into part 1, moving to text code. The first step on our journey today is a pretty exciting one. We're leveling up from visual, block-based coding right into the world of real text code. Now, a lot of you have probably used Scratch before, right? Scratch uses those colorful drag-and-drop blocks that just sort of click together like Lego bricks. And it's awesome, mostly because you never really have to memorize the code. But now, we're stepping into Python. Over on the Python side, the code is text-based. That means you type every single instruction yourself. Because of this, you do have to remember the correct grammar, which we call syntax. It might seem a little stricter at first, but trust me, it is way, way more powerful.
Oh, and before we get too deep into the weeds here, I just have to share this brilliantly quirky fact with you. You hear the word Python, and you probably imagine this giant slithering snake, right? Well, surprisingly, the creator of the language actually named it after a classic comedy TV show called Monty Python's Flying Circus. So whenever you're coding in Python, just remember, it's actually meant to be fun.
Okay, moving on to part 2, the IPO model. Let's look at how this builds the foundation of literally every app, game, or piece of software you've ever used. Every computer system in the world follows a super simple 3-step pattern: input, process, and output. Or, IPO for short. Think of it like ordering a pizza. First, you have the input. That's when you call the shop and tell them exactly what toppings you want. Next is the process. The chefs take your instructions, assemble the ingredients, and bake that pizza in the oven. And finally, the output. The doorbell rings, and a delicious pizza is delivered right into your hands. Best part, right?
So the crucial point here is how this actually translates to our secret language. In Python, input is the data you type in on your keyboard. We use a special command simply called input. When Python reads this command, it literally pauses the program, it holds its breath, and waits for you to type something and hit enter. The process is whatever the computer ends up doing with that information, and the output is what it shows back to you on the screen using the print command.
Which brings us to section 3, meet your variables.
But wait, hold on a second. If the computer pauses and I type my name into the keyboard, where does that word actually go? If the computer doesn't have a memory like ours, how does it remember what I just typed? Well, I want you to picture a variable as a little cardboard storage box floating around inside the computer's memory. When you create a variable, you basically write a label on the outside of that box. Then, you can put whatever information you want inside it. And the absolute best part? The information inside the box can change at any time depending on who's using the program, which is exactly why we call it a variable.
Let's actually look at some real Python code. Line 2 here says name equals input. So Python creates a box, slaps a sticker on it that says name, and waits for the user. If a student named Sami types her name, the word Sami gets dropped right into that box. Then, line 3 uses the print command. Look really closely at the formatting. Print, open parentheses, quote, hello, unquote, comma name, close parenthesis. This perfectly illustrates the speech marks rule. Text inside speech marks, like the word hello, is printed exactly as it's written. But the word name does not have speech marks around it. That tells Python, hey, don't print the word name. Go find the box labeled name, open it up, and print whatever is hiding inside.
Okay, time for a quick pause and think moment. I absolutely love doing these. I'm going to put you in the driver's seat for a second. Knowing that speech marks rule we just talked about, what do you think will actually pop up on the screen if I write print, hello, Sami, with quotes around both words? And what if I set a variable age equals 12 and then write print, quote, age, unquote, comma, age?
Did you figure it out? Let's check your logic. For the first one, because both words have speech marks, it prints exactly what is inside them, separated by a space. Hello, Sami. For the second one, it prints the exact text age, and then it grabs the number 12 from inside the age variable box, giving us age 12. It's literally like clicking Lego bricks together to build a sentence. Pretty cool, right?
All right, section 4, working with data types. Now, you might have noticed that a moment ago we put a word into a variable and then we put a number into a variable. Well, computers like things to be perfectly organized, so they actually categorize different flavors of information. Think of this table as your ultimate cheat sheet, so definitely pay close attention here. In Python, there are 3 main data types you're going to use right now. First up, an integer. This is a solid whole number, like 8, -3, or 250. No decimals allowed. If you do need a decimal point, like for money or measuring something, you use a real number, which is also known in Python as a float. Think 3.5 or 0.75. Finally, we have a string. A string is just text, literally a string of letters, and it is always wrapped up inside those speech marks we talked about, like the word DACA.
Once we have our numbers properly stored as integers or reals, we can actually ask the computer to do our homework for us. Python uses 4 primary mathematical symbols known as arithmetic operators. The plus sign is obviously to add. The minus sign is to subtract, but watch out for these next 2. We actually use the star or asterisk symbol to multiply and a / to divide. Takes a second to get used to, but you'll get the hang of it.
All right, let's put this all together with a little mini quiz. Take a look at this code. We've got a variable a storing the integer 5. We have a variable b storing the integer 4. Then we make a brand new variable called total, which equals a star b. Finally, we print the exact word answer followed by whatever is in the total variable. So think through the steps. What is going to appear on the screen?
Let's break it down like true computer scientists. Step 1, the box A gets the number 5. Step 2, the box B gets the number 4. Step 3, Python looks at total equals a star b. It grabs the 5, grabs the 4, sees that star symbol, and multiplies them to get 20. It stores 20 in the total box. Finally, it prints the exact text, answer, followed by whatever is in the total box. So the screen outputs answer 20. Brilliant!
And that brings us to our final section, testing and debugging.
You guys are doing fantastic so far. Now, what happens when things don't go according to plan? Because let me tell you a secret. In coding, things always go wrong at first. And you know what? That is perfectly fine. Making mistakes is just a normal part of the process. When your code throws an error or just doesn't do what you want it to do, you get to put on your detective hat and do something called debugging. Debugging is simply the process of hunting down, identifying, and squashing the errors, the bugs, in your program so that it runs smoothly.
To do this efficiently, professional programmers use project plans and flowcharts. So here is a final, provocative quiz question straight from your learning materials. What is the first thing you should check when you're debugging against a plan? Is it to just delete the whole program and restart? Is it to change all the variable names? Or is it something else entirely?
The correct answer is you compare the program to its flowchart. Your flowchart is basically your map. If you get lost driving, you don't throw your car away and buy a new one, right? No, you check the map. We've covered so much ground in this explainer today, from leaving Scratch behind to understanding the input-process-output model, filling up our variable boxes, and acting as code detectives. You now know the secret language. So I'm going to leave you with this thought. The next time you open your favorite app, I want you to ask yourself, what invisible variables are working behind the screen right now, just waiting for your input? Keep wondering, keep coding, and I'll catch you in the next explainer.